Yeah, good morning, everybody. As Annika said, we do this topic gas analysis for nearly 25 years next year, but we added a few components in the meantime, and I want to show you what else BlueSens can do and why we do that. Maybe just a first say introduction where we are. Indeed, we are located not in Berlin, as said. We are located in North Rhine-Westphalia, and especially in the Ruhr area. Everybody knows maybe Schalke 04. That's our club next to us, 5 kilometers away. And this region is known very, very well for coal mining. That means we had 4 coal minings here, or mines here, and that was Europe's greatest or biggest city for coal mining. But after everything was closed, they had to think a little bit different and find to get a change in here. That's what they did, and that's why we are here, starting in an incubator. But on the other hand, also Herten has some historical sites. We do have 2 castles. We do have also nice areas where you can have a nice view over the total Ruhr area, and it's not gray and dark and rusty. It's basically very green now. We do have some old villages here. That's very nice to see, and especially for bikers and mountain bikes, it's a good sport that you can do here. Okay, BlueSens headquarter is in Germany, Herten, as said. So we develop and produce our equipment here, and then we sell it worldwide. We do have a subsidiary in the US/Canada, but it's located in Wooddale. That's backdoor O'Hara Airport, Chicago, and that's a sales and service office. In addition, we do have several distributors working for us all over the world. And BlueSens, what are we doing? We produce and manufacture high quality gas analyzer for fermentation processes, or say there for bioprocesses. The software BlueVIS is also developed in-house, and next to the distribution partners, we also supply our technology to the top 10 of the global players for fermentation manufacturing devices. So if you do a fermentation, so I want to mix a little bit between some ideas why we use gas analysis, and maybe just a small fraction is some technical details. If you do a fermentation, you have a bioreactor somehow, doesn't matter the size here, but it's feeded, or a lot of data are recorded, like temperature, pressure, pH, DO. You also have a steering speed that can be logged. You have air supply. You have a flow rate of substances or substrates going like feed, pH, or say acid or base. That is recorded with a balance. You have an outgoing airflow. For example, in aerobic world, it's O2 CO2. In the anaerobic, it could be CO2 methane, hydrogen, something like this. And all this data can be, say, recorded and logged somewhere. That means you get really receive a lot of data, and the question now, what to do with this data? I think we do have some colleagues in here that also do some software and AI and so on. So this is what we live on, data. Let's focus on the aerobic world. In our case, we, for example, log data from oxygen and CO2. These are, in this case, monitored with our gas analyzer look a little bit different than maybe other machines. So this is a BlueVary, this is a BlueOne, and these are the first sensors we brought into the market, and some are looking like blue mushrooms. So that's very famous in the lab. The data that we get from here, same story. Somehow we need to use it, and the question finally is: does the concentration of a gas is the most important data or information, or is it something else? And I think you recognize my question is that you need something else. So using the concentration of gases and combine this with some other parameters, for example, with the liquid volume of fermenter, the gas flow that get out of the system, what is basically in most cases similar to the mass flow getting in, plus water that is added to the gas stream. And with these parameters, we can easily calculate, for example, OUR-CR-RQ. What is that? Oxygen uptake rate, carbon dioxide emission rate, and the respiratory quotient. And these are, we call it biological data, because this is are representing the metabolism of organisms that are living in this aerobic conditions. And this data are very valuable and make sense to use them somehow. And in our case, we started together with our software to calculate more than just these three values, but also you are able to also calculate biomass, grow rate, etc. from that. That's a little bit more complicated, but it's possible. So now the question always that we get, yeah, can we measure oxygen uptake rate directly? And just an example, it's not the case, to be honest. But there's a theory out there that helps us to understand that. And if you have a bubble of air going through a bioreactor, and then it's mostly air in or pure oxygen. And this oxygen needs to get somehow to the cell. And this is going into, basically the oxygen needs to be dissolved somehow in the liquid phase of a bioreactor. That's not so easy, but we don't want to go into details here, but just to give you an idea that you have a concentration of oxygen on the, on the layer here, and then it's somehow dissolved and needs to get into the cell there. So this is what they call OTR. So that means that it's the transfer rate of from the gas phase in the liquid phase, and that is what we basically are measuring. But to assume that the CO2 or the oxygen in the liquid phase is constant or nearly zero, because normally you have the cell always needs the oxygen here, and therefore the assumption is pretty simple, that finally calculating the OTR is this formula, and as an assumption is that oxygen uptake rate is near to the oxygen transfer rate. So this is the assumption that we have to do here to do this calculation. The CR is similar to that. What does this? What are the information that we get from that? Let's take, for example, an interpretation of the RQ value. And there's one nice case that is Baker's yeast at the end. Again, the respiratory quotient is just the carbon dioxide emission rate divided by oxygen uptake rate. And if you check the metabolism here, then you see if you have a, say, normal growth on glucose, you have enough oxygen in there, then carbon dioxide and water is produced, and the respiratory quotient stays near to 1. That's the ideal case for this kind of organism. Unfortunately, most of these processes, doesn't matter if it's Baker's yeast production or beer brewing, this is mostly not the case, because we do have glucose, but we mostly have too much glucose, and that is also another effect on that the yeast have a Crabtree effect called, if you have glucose above a certain amount plus maybe not enough oxygen, then you will immediately build alcohol. That's nice for some cases, but finally that brings us that the respiratory quotient hits or goes up. Mostly it's say not only 1.1 or something like that, it's going to 3, 4, 5, 10 or whatever, depending a little bit on the conditions. On the other hand, the good news is that yeast can also consume ethanol, and that helps, for example, in the baker's industry, that even if there is a small amount of ethanol produced, but it's consumed after a while. And what does it mean a while? It means when the original glucose source is depleted, and then it starts to consume the ethanol as another carbon source. The switching effect is, by the way, called dioxy. And this is what we can monitor with off-gas very easily, totally scale independent. That's maybe also something that have to be mentioned here, because the CROUR are calculated, and that means they are scale independent compared to the concentration. So we have seen also this tool already in a slide from Annika. So this is our multi-tool. And why is off-gas a multi-tool? For example, a respiratory quotient control for enzyme production, what is a big portion of the white biotech industry. So that's really a good market for using gas analysis. But also biomass estimation is possible with that. We also can reduce byproducts and also reduce the need of substrate by just feeding according to what the organism needs and not what the recipe tells us. We can organize or establish feed controls by the growth rate, and also very helpful for some processes as the batch and detection. I'm not going into details here, so if anybody wants to know more about that, feel free to contact me on the partnering platform, and then we can dive into details. So these are the gas analysis part, and now imagine that you can have a software which is modular and very easy to use. You can have mass and soft sensors without programming background, so you don't need to write a program for that. You also are able to connect new devices, but also old devices that are maybe on site and you lost the software. It's a Windows 7 software, whatever, and this maybe there's something out there that can help you. And it also helps you to maybe revamp or retrofit your old bioreactor, or also do it yourself bioreactor. And the software we're talking about is called BlueVIS. So this is our own software, starting 10 years ago, from being just a logging data software for gas analysis, is now a total control tool with a lot of features. So as we say, it's like a good wine. It's 10 years old now. So all the customer requirements are in there and implemented in there. So a lot of stuff that can help you. This is basically what it's doing. So you can add some sensors or sensor units that are sending the data into BlueVIS. Sure, whatever you do in the software, it's possible. And finally, most important is and interesting is to do something with it. So start a pump or control the steer or whatever is necessary. So BlueVIS itself is pretty simple, as we say. It's a little bit different from other control software that you may see. We are focused on data. It's not nice pictures. And so that's a pretty simple look here. It is made to control and monitor several processes in parallel. As said, we can connect sensors and actuators independent from the manufacturer. We have some protocols in there that are very easy to use and standard protocols, so that makes it easy to attach a different type of sensors. So it's not necessarily a gas sensor. We do have digital and analog. Wait a second, I stop my video. Okay, sorry. We can also add digital or analog signals. And finally, we do have an integrated OPC server, so we are open. We can deliver the data to other software packages. The automated calculation, as said, is in there already. Typical PID controller are available too, plus we call it sequence control. That means if you have a recipe and you want to run it in a timely manner, then it's possible too. I think one of the most interesting parts is our soft sensor area, where you can basically create a new value with a hardware sensor signal plus some calculation. So that's a definition for soft sensor. And this helps to get data immediately, or the data that you need and you want to have, and not do nasty calculation in Excel later. At the end, we always are interested to get more insight in the process, and obviously the best would be to use the data directly for process control. Sure, the most cases that are soft sensors are used is, for example, rate calculation. The PID controller is ready to go. That's nothing you have to build, but some new feeding strategies or signal smoothing, everything is available. How does that look like? Here you see the orange curve is basically a soft sensor, so we can build anything that you can imagine just with some logical components. So there's nothing that needs to be written as a small program. The reason is I'm not able to write programs, so my need was to have it as easy as possible. The platform or the surface looks a little bit like this, and this is just a small example. You can type in formulas in this area here, and also can do some small if and else inquiries to get data. You see we have 3 variables here that are different sources. For example, that's a balance or a scale. This is a control sequence that we need as a starting signal. And finally, this small tool was only made to calculate the weight of a balance that is lost over time to have the feeding over time. So it's pretty simple here, but can be done also to very serious and complicated tools if you need and want to. If it's too complicated, we normally start to implement that directly as a fixed soft sensor, as we call it, or plugin it's called. So it's also opportunity for customers to design own plugins, and then they are ready to go for also other users later. BlueVIS enables also to everybody, to be honest, to receive data from different devices, log the data, process the data, and it doesn't matter if it's an analyzer, a pump, mass flow controller, stirrer, pH, DO probe, and or a scale and balance. Everything is collected there. But there are still some data that are not directly available online. Everybody knows that. So that means we will have offline data. And this offline data can be imported in our software with our tool that's called BODI, BlueSens Offline Data Importer. And for example, a simple Excel file, but the BODI can also be configured to read complex TXT or CSV files where the information are a little bit hidden, but we can design it so that we can read the important data from that. So for example, HPLC or gas chromatography data are sometimes a little bit more complicated. And this is what we can also read and get it in here at the timestamp where the sample was taken. And this helps us to have all the data together. At the end, you also get a data format, even if you export it from BlueVIS again to process it with other software, but the data are already in order. So this can also be an opportunity to use this tool to unify data, or I don't know the word for that. But this is very important if you want to process data later on. And finally, our calculation is available to also help to scale up the process, organize the tech transfer, and finally help to optimize the process. So again, the respiratory control for some bioprocesses is very helpful. Biomass estimation is an add-on to real biomass probes. it's not a competition. It's basically an add-on and can help to extend ranges so that for example, a biomass probe is not so accurate at the end. So maybe that is what a soft sensor can help. The byproduct reduction is very important. So if you do know how much substrate, glucose, etc. you need to feed, you can reduce the byproduct and compared to just have a batch fermentation where you have a lot of glucose in there that do a lot of things that maybe are not wanted. The feed control by the macro growth rate is also very interesting. Batch and detection as said too. So finally, BlueSens is not only a gas analyzer company. We also try to understand your process. We do have colleagues here that can do data sciences, biotechnology experts that can help you to use the data to optimize your process, and the software is basically built as a tool to support this. So that's the thing that we can do. We can help to say optimize your process, your workaround. We are always looking for exciting collaboration with that are maybe difficult processes where the solution to scale up is not obviously, but also there are many things where people try to realize technical systems that are maybe not on the market, but I think we do have a lot of tools that can support that, especially with this use what you have technology, means combining old stuff and new stuff and bring all the data together in one tool. So that's basically what BlueSens can do. We are also available on some social media posts, but we are happy to talk to you directly. So that's mostly the easiest and best. So book your time here, or we also have a consulting area where you can book my colleagues and me to discuss more details. Thank you. So.